What's up, Gryffindors? It's time to double check our double angle formula problems. There's two ways that we can really think about this. One is we need to make sure that the sign of our answer is correct. And the other thing is we can guarantee our answer is correct by using our calculators. Now I want you to take a second to click mode on your calculator. And that's the button to the right of your blue button called second, right? So you want to click on mode. And I want you to change your calculator into degrees. It just helps us kind of understand how to do these problems a little bit better. Just keep in mind that you might need to go back to radians in the future, but not right now. All right, so on example 6, we did this problem and we found that our answer was negative 120 over 169. I want to take a second to see if our sign was correct, meaning should we have gotten a negative answer? Well, remember, we started at 3 pi over 2 and in between 3 pi over 2 and 2 pi. So we're something like this, right? And we've got 5, negative 12, and 13. Well, our first thing is to do is to kind of estimate that angle. And remember, each quadrant is 90 degrees. So we always start on the x-axis on the positive side. So we've got this angle right here. Okay, so this is just our reference angle in the middle right here. So we don't have to worry about that. What I really care about is how many degrees is that? Well, this here is 90. Now we're at 180, and now we're at 270, and then we've got a little bit more. Let's keep our math easy and let's estimate that theta is about 300 degrees, which would mean that 2 theta is equal to roughly 600 degrees. Okay, now the question is, where is 600 degrees? Well, what I like to do is I like to figure out, okay, how to subtract 360 from that and figure out what's left. So for example, if I have 600 degrees and I want to figure out where that is, I do 600 minus 360, and that gives me 240. Okay, so where is 2 theta? Well, let me go ahead and do a different color for 2 theta. So right now I'm going to draw 2 theta, which is 600 degrees, which is going to be a 360 and a 240, right? If you do 360 plus 240, you get to 600. So here's my 360, and now I need to do a 240. Well, that's going to be a 90, then a 180, and do I get to 270? No, I don't. I end up right here. So my 240 degrees ends up being right here. So my 2 theta ends up being in the 3rd quadrant. Now, we are asked for sine of 2 theta. Well, let's remember all students take calculus. So we've got all students take calculus. So here in the 3rd quadrant, we know that only tangent is positive and sine and cosine should be negative. So we are correct in thinking that we should have a negative. All right, let's try to actually get the correct answer and make sure that this is right. Remember, the answer that we got was negative 120 over 169, and it's going to be worth our time to just get the decimal version of that. And the decimal version of that is about negative 0.71. If you're wondering how I did that, I just plugged that right into my calculator. Okay, so now, how are we going to go about doing this problem? How are we going to go about checking our answers? Well, the key is to not estimate 2 theta at 600. We're actually going to get what 2 theta is and then take the sine of it. Well, the first step to find 2 theta in reality as opposed to guessing is to do inverse trigonometry. So remember, we've got a triangle right here with a theta, with a 5, negative 12, and a 13. And we're going to do inverse trig. Well, we're already told that sine theta is equal to negative 12 over 13. So what we're going to do is we're going to do sine inverse of negative 12 over 13. And that gives me 67.38 degrees. Now, if you get a negative on these answers, just make it positive. We don't care about the fact that it's going down. We just care about what it is. Okay, so if that's 67.38 degrees, I'm going to put that in here. So this is 67.38. And what do I really care about? Remember, I really care about getting theta. My angle for this problem is this. Okay, I really want this. Well, what's that going to be? So my theta actually in this problem is going to be 360 minus this right here, because I want to get that red. Well, 360 minus that, what does that give us? That gives us theta is equal to about 292.61 degrees. So I was pretty darn close in guessing 300 degrees, but I was not accurate. All right, now, if that is theta, what is my 2 theta? Well, 2 theta is just going to be 2 times that. And so that's going to be 292.61 times 2 is roughly 585.22 degrees. So now what I'm going to do is I'm going to do sine of 2 theta. Well, what is sine of 2 theta? Well, sine of 2 theta is going to be equal to sine of 585.22. Okay, what is that equal to? That is equal to sine of 2 theta is equal to, I put this right here in my calculator, and I get negative 0.71. Now you should notice right here that we are happy because we got a negative 0.71 from doing this fraction, and here we got a negative 0.71 from finding out what 2 theta was and then just plugging it into sine. All right. All right, let's just make sure that our example 7 is correct here. First, let's make sure our sign is correct. By sign, I mean, is it positive or negative? Here we got negative, and let's just make sure that makes sense. So the first thing we do is kind of estimate, right? So here in this problem, we're between pi and pi over 2. So here's my pi over 2, and here's my pi. So I had a triangle that looked like this, and as you recall, it was 3, negative 4, and 5. Okay, let's go ahead and let's estimate that angle. So what angle am I talking about? Remember, we're talking about from our positive x-axis to here. Well, from here to here is 90 plus a little bit. Let's go ahead and guess that that is, I don't know, 100 degrees. So we'll say theta equals 100 degrees. So that would mean that 2 theta is equal to 200 degrees. Well, where would 200 degrees be? Okay, let's make this green again. Let's talk about 2 theta being green here. 2 theta. 200 degrees is going to be a little bit more than our, 200 degrees is going to be a little bit more than 180. So we're going to go into here. So here we are in the 3rd quadrant for 2 theta. Okay, so 2 theta is in the 3rd quadrant. Well, what does that mean if we're asking for sine? Remember, all students take calculus. All students take calculus, so only tangent should be positive, so here our sign should be negative. So the fact that we got negative is good. All right, so that was just kind of the estimating way to guess, to double check that your answer is right. Now let's go ahead and actually calculate that correct answer. And let's do this math in our calculator right now. And when I do that math, negative 24 divided by 25 is a negative 0.96. So I want to get negative 0.96. That's what we got from that. Let's see if we got the right answer. Well, let's draw this little shape again here. We know we're like this, and we've got our 3, negative 4, 5. And you don't really have to do this, but I think it helps just kind of visualizing what our theta is going to be. So here, let's find what this theta is first. I know I'm using theta for two different angles, but that's what we kind of do. So that angle right here, what is that equal to? Well, that's going to be equal to cotangent inverse, right? Cotangent inverse of -4/3. Unfortunately, we don't have cotangent inverse on our calculator. We do have tan inverse though. So I want to rewrite this equation as tangent of theta equals -4/3. Right? What do I have to do? I have to flip them, right? Because this is cotangent of a -4/3. So I've got to flip it to be 3/-4. So if I want to find what this angle is right here, I need to do tan inverse of 3/-4. And what do I get for that? I get a -36.869 degrees. Remember, I told you to keep it positive. So in this case, we've got 36.869. All right. Well, how are we going to find this answer? We're really looking for what this angle is right here. Well, what is that angle? That's going to be 180 degrees minus that black degree, right? Because you can see here, I shouldn't have done that. I knew it. I was doing it. I was like, Miss Sorensen, you shouldn't do that. Anyway, we got to do 180 minus whatever this black angle is in that middle there. So that's 36.869. And that gives me that my theta is equal to 143.13. And you can see my guess was off quite a bit. And I kind of knew that. I only added 10 degrees from 90, but no big deal. So what's my 2 theta going to be? So my 2 theta is just going to be double that. Well, doubling 143. What is that? That's going to be 286.26. And again, yeah, that is in the third quadrant, so we're happy about that. So now I want to find sine of 2 theta. That's really what we're looking for. So that's going to be sine of 286.26. I get that answer, and that answer is -0.96. So are we happy? Why, yes, we are. We get a -0.96 and a -0.96 here as well. So we know that we got our answer correct. Now, some of you might be saying, hey, Ms. Sorensen, I like this way better. And the unfortunate thing is on your final, it says give the exact answer. Which one's exact? -24/25 or a -0.96? This is the exact answer. These -0.96s, they are rounded. So on your final, when I ask you for the answer, you have to leave a fraction. And you can use this method to check your work, but you're going to have to answer as a fraction. All right, last one here, folks, and then we're done with double checking our double angle formula. On example 8, we got sine of 2 theta was 80/89. Let's go ahead and let's draw this. Remember, we're between pi and 3 pi over 2 on this problem, so we're definitely right here. And our triangle looks like a -5, a -8, and a square root of 89. All right, let's estimate that angle. Well, I'm going to estimate that angle as being more than 180, right? So we've got our 90, our 180, and then a little bit more. So I'm just going to go ahead and I'm going to estimate it as, let's say, 240. So we'll say that theta is 240, which means what's our 2 theta? Well, that means our 2 theta is going to be double that, which is going to be 480. Well, what does 480 break down into? That's a 360 and a 120. Okay, so my 360 is going to go around once, and then I've got a 120, which is going to be a 90 and a little bit more. Okay, so my 2 theta is going to end up in the second quadrant. That's where my 2 theta is going to be. And remember, all students take calculus. All students take calculus. So here, sine should be positive, and we got a positive answer. So we are wicked happy. All right, last thing that we're going to do here is actually find the right answer as a decimal. And I'm going to take my 80 over 89 and I'm going to get a decimal for that. And our answer that we got as a decimal is a 0.8987. And we're hoping that by doing our check step, we're going to get the same answer. All right, so here's my coordinate. And again, we were here. So that's a theta, -5, -8, and square root of 89. So let's find that theta. That theta is going to be tan inverse, I'm getting that from this right here, of 8 over 5. That's how we find angles, by doing the inverse function. And I get 58 degrees, almost exactly. Again, remember, if you get a negative, no big deal. We're just making that positive. So here, in this little section right here, we've got 58 degrees. Well, what is that 58 degrees? That's going to be added to 90 and a 180 here. So we've got 180 and then we've got a 58. That gives us that whole angle. So what we're doing is 180 plus 58 is going to give us our answer for theta, and our theta is going to be equal to 238 degrees. Now, I have to give myself a little pat on the back here. I guessed it as 240, so go Miss Sorensen. I win a prize. Who would like to give me a prize? All right, so if theta is equal to 238, what is my 2 theta equal to? Well, obviously multiply that by 2. And we get 2 theta is 2 times 238. Give me 1 second there. That is going to be 476 degrees. And again, I'm really close to my guess over here for 80, but not perfect. So now I need to take sine of 2 theta. Well, sine of 2 theta is going to be equal to sine of 476. And sine of 476 is 0.8987. And I'll be a monkey's uncle. Take a look at what we got and what we got from doing the check step. All right, that's it, folks. Hope you enjoyed being able to check your answer, and I hope you have a fantastic day.